The combustion system of this gas turbine is a reverse flow type with 14 DLN1 can-annular combustion chambers arranged around the periphery of the compressor discharge casing. Combustion chambers are numbered counterclockwise as viewed looking downstream starting from the vertical center line. With dual fuel capability, this turbine burns either gas fuel or liquid fuel. In this section, the pressurized compressor discharge air is directed upstream to enter the combustion zone, mixed and burned with fuel, producing hot gases, which will drive the turbine. The combustion system main components are the combustion wrapper, combustion can cover, primary fuel nozzle, secondary fuel nozzle, the liner, flow sleeve, transition pieces, crossfire tubes, spark plugs, flame detectors. The combustion wrapper is a fabricated horizontally split casing that encloses the combustion system. It provides a supporting surface for combustion chamber assemblies. The wrapper forms a large plenum, which receives the compressor discharge air. This air is directed upstream to the combustion chambers. The forward face of the wrapper is slanted at 13 degrees angle from the vertical and contains machined openings to mount the 14 combustion chamber covers. The wrapper is supported by the compressor discharge casing and the turbine shell. The combustion chamber cover function is to carry the combustion chamber components. The flow sleeve is mounted on the combustion chamber cover. The flow sleeve forces the air to move upstream, forming a uniform air jacket around the liner for precise combustion and cooling functions among the 14 chambers. The liner is the core of the combustion system. Inside the liner, air and fuel are mixed and burned, providing hot gases. The liner is mounted on the flow sleeve at the forward side by 3 liner stops. And supported at the aft by inserting the liner inside the transition piece. This configuration allows thermal expansion of the liner. Spring seals located at the aft end of the liner to prevent the compressor discharge air from leaking into the hot gas path. The liner consists of the liner body, multi-nozzle cap assembly, and the venturi. These parts are assembled together by rivets. Combustion air flows into the liner through various locations. Primary combustion air flows through the primary gas tips. Air enters from metering holes for combustion functions. Secondary combustion air enter through the center body. Dilution air enters the liners from 3 holes at the aft side of the liner. Due to the extremely high temperatures encountered inside the liner, all surfaces which are exposed to the flame are protected by thermal barrier coating. The combustion liner is also protected by film cooling, as air flows through the liner cooling rings to make an air film adjacent to the liner surface. This air film keeps the hot gases away from the liner metal. The liner cap is protected by film cooling and backside impingement cooling. The venturi is cooled by backside impingement cooling. All combustion chambers are interconnected by means of crossfire tubes. These tubes enable flame to propagate from one chamber to another. Crossfire tubes are couples of male and female parts. Each is inserted into the liner crossfire tube collar and held on position to the bracket on the flow sleeve by the crossfire tube retainer. All crossfire tubes are surrounded by crossfire outer tubes. These tubes connect the combustion chamber outer covers together. Packing is installed to minimize leakage and held by flanges on both sides of each tube. Outer tubes are prevented from sliding by split retainers mounted on the flanges. As the DLN1 system features two combustion zones, fuel is injected to the combustion chambers through the primary and the secondary nozzles. The primary fuel nozzle is functionally integrated with the combustion chamber end cover and provides a flange in the center for secondary nozzle mounting. Fuel is injected into the liner primary zone through 6 identical nozzles. Gas fuel enters the primary nozzle's assembly through the fuel-gas connection flange and is routed through internal machined passages to the orifices located in the gas tips. Atomizing air is introduced in the same manner through internal passages and exits to the primary zone through multiple holes on each of the gas tips. Water is supplied to the primary water injection manifold, then distributed to the 6 nozzles through piping to each one of the fuel oil flange and tip assemblies. Liquid fuel is supplied to a liquid fuel distribution valve to equally distribute the fuel across the 6 nozzles, especially on startup. Fuel flows through piping to the primary zone through the liquid fuel tip located at the center of the gas tip. The secondary nozzle features a supply flange for secondary gas fuel, which is injected into the secondary premix zone through multiple holes. A small amount of the secondary gas is injected after the secondary swirler. This amount is called the secondary gas subpilot. This amount of gas promotes the secondary flame stability. Transfer gas for transient transfer operation is supplied to the relevant supply flange and is injected before the secondary swirler also. Liquid fuel and water flow from the inlet flanges to the combustion zone, where they are injected at the aft tip of the secondary nozzle assembly. Combustion is initiated by means of 2 spark plugs mounted on the 11th and 12th combustion chambers. The spark plug is mounted on the spark plug ball joint. This joint allows adjustment of the spark plug relative to the liner. On a DLN1 combustion system, spark plugs remain inside the liner throughout all the operation for startup and primary zone reignition functions. Once the flame is started on these chambers, it propagates to the other chambers through the crossfire tubes. Flame is detected on combustion chambers by means of ultraviolet flame detectors mounted on 4 chambers, the 14th, the 1st, the 2nd, and the third combustion chambers. As the DLN system features 2 combustion zones, flame is detected by 4 flame detectors in each zone. The flame in the primary zone is detected by flame detectors mounted on pads on the combustion chamber cover. This detector is inclined to detect the flame through one of the metering holes around the liner body. Secondary flame detectors are mounted on the secondary nozzle flame flange. Flame is detected in the secondary zone through a viewport in the secondary swirler. Transition pieces are the interface between the combustion and the turbine sections. They direct the hot gases from the liners to the turbine first stage nozzles. The first stage nozzle entrance area is divided into 14 equal areas, receiving the hot gas flow. Due to the extremely high temperatures of the passing hot gases, the inside surface of the transition piece are coated with thermal barrier coating. Cooling air is introduced by allowing compressor discharge air through the vent plate to the cooling holes machined on the transition piece aft end. The transition pieces are sealed to both outer and inner side walls of the first stage nozzle by the outer and inner seals. These seals are inserted into grooves on the first stage nozzle to minimize compressor discharge air leakage into the hot gas path. The sides of the transition pieces are sealed by side seals. Side seals are held in position by side seal retainer blocks. These blocks are mounted on the first stage nozzle retainer ring. Transition pieces are supported at the aft side by means of the aft mounting bracket, which is mounted on the first stage nozzle retainer ring. Each transition piece is supported at the forward side by a support clamp. This support clamp is mounted on the compressor discharge casing.